Sharan, I am there. Hello?
Yes, sir. So can we begin?
Yeah. We'll wait for another 2 minutes.
Good afternoon, everyone. It's my pleasure to welcome you all to the Technical Talk series titled TransTech Talk Series, organized by KSCSTE National Transportation Planning and Research Center, NATPAC. Through this Technical Talk series, we aim to provide a platform for experts in the respective fields to share their knowledge and expertise with us. This talk will give us insight into the latest developments, emerging trends, and cutting-edge technologies in the transportation field. Today, the fifth talk in the series will be delivered by Dr. Varghese, Assistant Professor, Transdisciplinary Science and Engineering Program, Graduate School of Advanced Science and Engineering, Hiroshima University, Japan. Now, I would like to invite our director, Dr. Samson Matthew, to deliver the welcome speech.
I don't have a headset. I know what to watch.
Over to Samson, sir.
Yeah. Good evening. Good afternoon, and good evening to Dr. Varun. In fact, I'm traveling with a small delay in that. I hope, Shahim, I'm audible now?
Yes, sir. Yes, sir.
Okay. So, welcome all of you to this fifth TransTech topic organized by National Transportation Planning and Research Center. I mentioned in our my previous the programs. So the NATPAC started in the year 1976, and now that we are with the Kerala State Council for Science and Technology, Science, Technology and Environment from 2002, and we work on multimodal disciplines, especially in transportation engineering related topics, traffic engineering, transport planning, public transport, highways, and structural engineering, pavement engineering, etc. In fact, our research and development is governed by a research council. Currently, Professor Tommy Matthew of Department of Civil Engineering, IIT Bombay, is the chairman, and the experts from academia, then CRRI, etc., are the members. We are organizing this series of monthly online lectures, TransTech Talk series, basically to give idea about the new topic or the ideas to the students, stakeholders, researchers, etc. Previous 4 talks, we have seen that one good number of students, especially the research college, the people working in the field, then the faculty that they attended. We started our first program by a lecture from Dr. Srinivas S. Fulgutra on advanced crash frequency prediction modeling using GES. Then we had Dr. Rajib B. Malik, who talked on challenges and solutions in cold asphalt pavement recycling. Third one by Professor R. Jayashan. It was on the topic traffic signal control of the future. And the last one, fourth one, was on application of safe systems approach using crash data analysis by engineer Tony Matthew. from TRL. Today, we have with us Dr. Varun Varghese, Ph.D., who is currently working as assistant professor at the School of Advanced Science and Engineering, Hiroshima University, Japan. I welcome Dr. Varun Varghese to this program as well as to NATPAC. In fact, today's talk is organized by the Water Transportation and GS division of NATPAC. The division comprises of basically 3 scientists headed by Mr. Sharan, M.S. Sharan, the scientist in charge of the division, and who is assisted by Dr. Sabida N.M., senior scientist, as well as Dr. Remisha TV. Diba Radhakrishnan is a technical officer with the division. The main function of the Water Transport and GS division is to undertake research and consultancy studies related to inland water transport, coastal shipping, mobile application development, and GAS. I just wanted to mention a couple of major projects undertaken by the division. The preparation of detailed project report for the development of inland waterways between Kovalam and Kollam, taken by Dr. Sabida. Then one ongoing project is on DPR for integrated urban regeneration and water transport in Cochin. We already conducted the study on the National Waterway 3 towards north of Kottapuram and towards south of Kollam. This was regarding the water transport. Stern has taken up forecasting urban growth based on GS, remote sensing, and urban growth margin model for growing cities in Kerala. Preparation of detailed road transport map for Kerala using GS, remote sensing, and GPS. The newly added scientist Dr. Remisha has taken up a project of a feasibility study of cargo shipping from Cochin port to its hinterland and other minor ports in Kerala. With this introduction about the division, I welcome all of you once again to this TransTech series. Good day to all of you. Thank you.
Thank you, sir. Now I would like to invite Sri M.S. Sharan, Scientist in Charge, Water Transportation and GIS Division, NATPAC, to introduce our distinguished speaker for today's section. Over to you, sir.
Thank you, Sharon. Dr. Varun Varghese is Assistant Professor at the Transdisciplinary Science and Engineering Program, Graduate School of Advanced Science and Engineering, Hiroshima University, Japan. He primarily works in the field of transportation planning. His research interests involve the empirical analysis of the impacts of travel behavior on the environment, travel behavior during disaster, interrelation between ICT and travel demand management strategies for sustainable transportation. He is a civil engineer with a bachelor degree from Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, master's from Sapt University, Ahmedabad, and a PhD from the Indian Institute of Technology, Bombay. Prior to joining as assistant professor, he worked as a postdoctoral researcher at the Infrastructure Planning and Urban Risk Management Lab at Hiroshima University, where he worked for a project funded by the Ministry of Land, Infrastructure, Transport, and Tourism, Japan, on the application of advanced machine learning techniques for transportation planning and management. With this brief introduction, I would like to invite Dr. Varun Varghese to deliver the talk. Over to you, sir.
Thank you so much, Sharan, sir. First of all, I would like to thank NATPAC for the invitation, Dr. Ramisha, Dr. Shabika, and Sharan sir for the kind invitation, and all the other members at NATPAC. I would also like to extend my thanks to Dr. Samson Matthew for the very nice introduction. I was enlightened by the different kinds of studies that is happening at the center. And with that, I would like to start my presentation. So I will just share my screen. Is my screen visible?
Yes, yes.
Okay. So thank you again. So in this talk, what I will try to introduce is basically a study that we did in Dhaka, Bangladesh, where we tried to quantify the trade-off between environmental sustainability. And I'll explain what we defined as environmental sustainability and the equity in welfare. The study was done for the mass rapid transit system, the metro system of Dhaka. It just started. It started last year, and we did it through a stated preference survey. So I will introduce the findings of our research, and I will also try to kind of highlight why quantifying this trade-off is important, especially in the countries of Global South. And this is how my presentation has been structured. So first, I'll briefly introduce the topic, where I would try to define the meaning of environmental sustainability in the context of our research, equity and welfare, and how both of them are linked when we look at them through the lens of comfort in public transit. And by comfort, we specifically try to understand crowding in public transit. And then I will move on to uh, describe our study area and the survey that we did in the uh, research. And then I would describe how we kind of estimated the impact of crowding through a PPR type function. I'll take my time to introduce the function. It's the public, sorry, Bureau of Public Road type function. This function is very common in traffic studies. So we kind of use that function to capture the impact of crowding on the mode choice utility. So I will take my time to describe this uh, function and the equations. And then I will try to explain how the different sensitivity to crowding impacts the demand for MRT, and how does that impact the total car use within the city of Dhaka. And then finally, I'll conclude this talk by discussing the key findings and the directions for future research. So this particular work has already been published, and I have shared my slides with Saran sir and Ramisha ma'am. So if anybody is interested, please go through our paper and go through the slides. So we all know that transportation is one of the leading contributors towards global CO2 emissions. And at that too, 75% of the total emissions from transport comes from road transportation. And reducing CO2 emissions will help us attain a wider level of sustainability. And within road transport also, a major contributor is car. So we can see that car is just second to aeroplanes. So we have to understand that who uses car. There is again a major difference between, say, developed countries and the countries of global south, including India, where use of car is more prevalent across higher income groups. And there are many studies which delve into the psychological reasons behind why people buy cars and use cars. And one of the common reasons is that they buy cars because it makes them feel like they are doing well in their life. It is kind of a status symbol. So traditionally, cars are used by people who have a level of income. And even though that percentage is still very low in India, it is supposed to grow, and it will grow in the future, and it has a lot of externalities. So we know that it causes very high levels of congestion, very high levels of CO2 emissions. So there is some amount of requirement in the sense to study who kind of uses these cars, but our study basically try to understand why they prefer car as opposed to public transit, in the sense how much do they value the uh, comfort levels in public transit. And what it would take to make these public transit systems comfortable for these high income users so that they shift from their current use of car to public transport systems. And then the second aspect that we are focusing on in this research is the aspect of equity. So if you just look at the dictionary definition of equity, I just searched on Google, it just means that it's the quality of being fair and impartial. So if we have a new transit system being introduced, so this is a photo from the transit lines which are planned in Dhaka. So one of the lines is already functional, and the others are being planned in the next 5 to 10 years. So when such a new transit system is introduced, how do we ensure that the benefits coming from this transit system kind of reaches to all sections of the system, all sections of the society, and these benefits are distributed fairly? So the benefits could be that many areas which were previously not accessible are now accessible due to this MRT system or any transit system. It will save the travel time, so that has an indirect economic benefit, and it will also decrease the overall emissions and the uh, environmental pollution within the region. So when we have these benefits, it's clear that a public transit system has these benefits, but how to ensure that these benefits are distributed fairly across everybody in the society. So these are the two aspects that we are focusing upon. And when we look at both these aspects through the lens of crowding, what we basically can see that, okay, the first point is that the benefits of a transit system can be made available to everyone if transit is operating at a very low fare, so that it is at least economically accessible to everybody. Also, we have other aspects like making it more accessible in terms of distance and time. But one of the major points here is that economically, like the fare of the public transit system should be low so that everybody in the society can make it, can use it. And the second part is that uh, this particular system might improve the environmental sustainability when car users shift from their car to this particular mode. But these particular car users are high income users who might value crowding very highly. So they would not want to travel in a public transit system if it's extremely crowded. And if we reduce the price of the MRT system to be very low, naturally the system will get very crowded, and that would make high income users stay away from the system or kind of want to not use the system and continue in their current mode of transportation, that is cars. So there is a very natural trade-off. In this study, we are not trying to give any value judgment, as in a particular system is right or wrong. Our attempt was to just quantify this existing trade-off. So with that idea, what we wanted to do is that we wanted to test how different income groups value crowding and how does that then impact their demand of MRT. And through that, we kind of quantify the trade-off. And again, like this is just a small introduction on the crowding itself. There have been many studies from India also and across the world how crowding is one of the major roadblocks which hampers the attractiveness of public transit systems beyond the captive riders. Of course, if you don't have an option, you use public transit, but how can we make it attractive so that everybody, even high income car users, uses public transit? So crowding has been identified as a major roadblock. Crowding's impact has been studied with reference to route choice, fare optimization, waiting time, travel time reliability, and even well-being of travelers. And what during this research and trying to understand the gaps in the literature, what we observed that very few studies kind of uh, quantified the heterogeneity across income groups. In fact, a couple of studies from India did, and so we wish to kind of extend that literature and add on to that, also test how that heterogeneity in the sensitivity to crowding kind of results in the variation of demand for MRT itself across different income groups. So broadly speaking, this research has two objectives. The first objective is to see how the impact of crowding varies across income groups, and we do that using a mixed logic model. And the second is to do multiple scenario analysis by varying the fare and capacity of the metro system, and then see. So the first step, we kind of identify, okay, each income group uh, values crowding in this particular way, and using those particular sensitivity, we then estimate their demand when fare and capacity is being varied across different scenarios. And we do that through a stochastic usual equilibrium approach, which is also common in traffic studies. So I will also explain these equations in detail. And what we try to find is basically the equilibrium demand for MRT across different income groups. So based on these objectives, we kind of set out to collect data from Dhaka. So the study area is, we just selected a fixed OD. So people residing in one part of Dhaka traveling to the CBD. So all our travelers are traveling between this OD. It was intentional. We understand that this kind of limits the representativeness of the entire region, but the reason behind this was we could then control the other options available to them in the model so that the model itself can be more reliable in terms of the values of travel time and travel cost in other modes apart from MR. So we we do the survey between a typically high-end residential area in Dhaka, traveling to the CBD of Dhaka. And Dhaka also, like many congested Indian cities, is highly dense, and there exists high level of income disparity. So there are people who are extremely rich, and there are also people who are very poor. So with that aim, we kind of did a stated preference survey for people traveling between this OD. And then uh, this is how the stated preference survey looked like. So we had specifically 4 alternative specific attributes. So these attributes we varied based on 3 levels for travel time, fare, and the frequency of service. So this is like the headway, like how frequently the metro would come. And then we showed them some show cards for the different levels of crowding. And each crowding had a objective continuous value also attached to them in terms of the occupancy level. So these show cards basically, to make it more random and orthogonal, we adopted a fractional orthogonal design, which resulted in 18 sets per person. But 18, like asking one respondent 18 times was a bit too much. So we decided to randomly select 6 out of this 18 sets and ask each individual. So we surveyed around 300 and actually we surveyed around 450, but the clean data is around 361 respondents who responded 2,125 times. So each of them were given multiple show cards by varying these levels of travel time, fare, frequency, and crowding level. And then they were asked to choose whether they would choose the new MRT system or they would stick to their previous mode. And we did an additional RP survey for their existing mode, where they choose either car, motorcycle, or bus. And we also asked the crowding level in bus, for example, and the travel time and the travel cost in bus and the other modes. So this is how the data looks like. So this is the present uh, travel mode in Dhaka during our survey. So we could see, sorry, this is not the, this is the present travel mode, and this is the present crowding in the bus. So we could see a very high percentage, nearly 40%, not 40, sorry, nearly 20% of the people reported a very, very high levels of crowding in the bus. And this is the present distribution of the transportation mode, where we could see nearly 3/4 of the respondents we surveyed used bus. And then this is the distribution of the income. Uh, so around 24% of the respondents belong to a lower income group, which was below 50,000 Bangladesh Taka. So one Bangladesh, so it's around 20,000 to 25,000 rupees. I understand that this is not so low, but this is again coming because this is again happening because we sampled one set location of origin and destination where usually users were of high income group. And our idea was also to capture a lot of car users to really know their uh, sensitivity towards crowding and their preference of car versus MRT. So that's why the income groups looks slightly skewed, but we somehow divided these income groups into three discrete groups, and then we also estimated the models based on these three groups itself. And then after we showed them the SP choice, so this is how the mode choice looked like. So after the SP choice, 49% of the respondents out of the 2,125 responses said that they would shift to MRT. And we could see that where this shift is coming from. So a very high percentage of bus users are shifting to MRT, and some percentages of car and two-wheeler users are also shifting to MRT. So based on this initial descriptive analysis, we kind of employed the logic model, the mode choice model. So this is how the utility equation looks like. So we have a variable for travel time, the headway, the frequency, the travel cost, and firstly, we tested the impact of crowding as a dummy variable. So we have 6 levels of crowding. So we included 5 of them in the equation in interaction with travel time. So the idea is that longer the travel time, higher would be this crowding's impact on their utility. So first we tested the impact on their utility and their mode choice using these dummy variables, like one variable for each of the 6 uh, levels of crowding. And this is what we observed. So we could see that the crowding level, the crowding cost is just the beta for crowding divided by the beta for cost. So this kind of basically, in very simple terms, it tells us how much these respondents value crowding. So at the higher levels of crowding, we could see the difference between the high and low income groups. It kind of like almost more than double in terms of cost. So what we tried to then do is that test the impact of crowding not as dummy variable, but as a continuous variable. But we were also kind of conscious of the fact that if we include crowding as a continuous variable, like in terms of capacity or in terms of flow, what is happening is that the impact will not be linear. That is, 1 unit of increase in crowding will not result in 1 unit of decrease in utility. The impact might have some exponential component to that. And to do that, so this is just the results of the dummy models, like where we incorporated crowding as a dummy variable. So now I will introduce how we incorporate it as a continuous variable. So we incorporated it as a BPR type function. So a BPR type function typically looks like this, where the numerator is the actual number of passengers in the MRT system divided by the capacity. And we have two parameters controlling this. So one is called the scale parameter, which is similar to like a beta in the previous model. And we have one exponential parameter rho, which also kind of controls how, for example, in higher levels of flow, the impact of crowding might be higher. So that's to account for that, we kind of included this exponential factor in the model. And again, this also is multiplied by travel time, because the longer you stay in a crowded situation, the higher would be its impact on utility. So now, in a typical mode choice formulation, such an expression is very difficult to estimate. So what we did is that we did a kind of a grid search where we kind of varied row in each iteration, say varied it 0.1 at a time. So first we check the mode choice model when rho is 0.1, and then we estimate all the beta and the gamma parameters. Then we estimate again when rho is 0.2, then 0.3, and then we select the model which gives the highest log likelihood. And this is just the formula to estimate the probability of selecting the mode. This is very simple to a typical multinomial logic model. Just the difference is we add additional error component here to account for the panel effects, because we are asking each person 6 times. So to account for that kind of multiple responses from the same individual, we try to kind of account for inter-individual heterogeneity through this additional error component. So this is just the equation, because this error component has to be integrated across all the users. That's why there is an integral, but basically it is very similar to a simple multinomial logic model. And by estimating this model, what we basically get is the values of sensitivity for each of these variables, and then kind of a prediction of probability of how probable are people to choose a particular mode of transport across different income groups. Now I will just briefly explain this grid search approach. So this is how it looks like. So we varied row one at a time for multiple iterations. And so this is a graph which shows the log likelihood of the entire model at each iteration when we were varying row. And then for each different income group, we selected the model which produced kind of the highest log likelihood value. So this is how the final model looks like. So I would just try to then conclude this part by showing the crowding cost when we included crowding as a continuous variable through a BPR type function. So here again, we could see the results are very similar to when it was tested as a dummy variable, but here we can calculate the impact of a continuous flow value. So later on, when we are trying to estimate the flow of MRT in the entire region, we can use this model, because this model would directly give us, okay, for this flow, this is the probability of choosing car or choosing MRT or for choosing bus. So that was the basic idea why we wanted to include this continuous value in the equation. And this is just the distribution of crowding cost across income group. So we could see that the higher income group values crowding extremely high as compared to middle and low. And the definition of high, middle, and low is the same one as I described in the previous slide. So based on that, we did the scenario analysis. So I will now try to explain the steps behind the scenario analysis and the stochastic user equilibrium approach. So the idea is very simple. So we want to reach to a user equilibrium of flow where the value of flow in the previous iteration doesn't change much in the current iteration. So the idea here is that we start off the iteration with a very random value of flow. Suppose, say, 1,000 people in the entire region is going to choose MRT. Now, as we see, this number of people using MRT would impact the utility, that would impact the probability, and that would again impact how many people would choose MRT, right? So the number of people choosing MRT is dependent upon the current flow, because each group has different sensitivity towards crowding. If there are a lot of people choosing MRT, then high income people would not choose MRT because their sensitivity to crowding is very high. So this is just controlled by this equation. So if there are a lot of people using MRT, the utility of choosing MRT and the probability of choosing MRT will be low for each group based on their sensitivity to the crowding. So that is how we estimated an equilibrium flow where suppose we did multiple iterations. So we reached at a point where the difference between the two iterations is almost negligible. So we have now reached at a point we could say, okay, at the estimated levels of beta from the mode choice model, we could safely argue that this would be the amount of people choosing MRT, bus, two-wheelers, and car when the fare is X and the capacity is Y. So we change the fare and capacity in multiple scenarios, and then we try to quantify how many people would use these different modes based on the beta parameters estimated in our mode choice model. And we also estimated the values for user surplus, which is kind of an indicator for the welfare of consumers. This is just through a typical mode choice framework. This is, in simple terms, this is the total number of options available to them. So this is the summation across all the modes utility. So this divided by the cost parameter would give us the user surplus. The log sum divided by the cost parameter gives us the user surplus, and the same user surplus summed across all the users in the particular income group would give the user surplus across the income group, and then that summed us, that the user surplus multiplied by the number of people in each income group would give the total user surplus of the people in that income group, and that summed across different income groups would give the total consumer surplus of the entire region when such a system is being introduced. And revenue is simply the number of people using the mode multiplied by the fare. And the total surplus of a system is actually the consumer surplus plus producer surplus, and producer surplus is basically the difference between revenue and the cost to the producers or the suppliers. But in this survey, in this study, we did not have the cost to the producers, which is like the maintenance cost or all the costs associated with running a public transit system. So we just assumed that the revenue, the sum of consumer surplus and revenue is like the total surplus of the entire system, which includes consumer surplus and producer surplus. So these are some of the assumptions that we had to do the fare and capacity analysis. So this is how we varied the capacity and the fare. So we varied it like keeping all the other factors constant. So we first varied fare and then we varied capacity. So a multiple number of scenarios were generated, and we made some assumptions about the peak hour passenger traffic in Dhaka based on some secondary data we had. And this is the distribution of the income groups, again, based on the same JICA report. And then so we ignored road congestion, which is a limitation of our study. It's natural that the level of congestion on road will also impact the choice of people of MRT and other modes. But we assume that the road congestion is constant across our scenarios. And we also assume the crowding in bus is constant across our scenarios. So these are two limiting assumptions of this particular analysis. But our basic idea was just to kind of show the differences between preferences of people and how that impacts demand. So based on these assumptions, we kind of did the analysis, and this is how the metro flow looks like. So if you see, so on the x-axis, we can see how we varied the price, and this is the flow of passengers per hour in that direction. And this is the capacity of the metro system. So a natural solution is just having a very large capacity so that it's never crowded, but we know that that's not practically possible. So we try to see what kind of scenario results to what kind of equilibrium flows. So we could see that the flow for low income and middle income group is highest when the fare is the lowest. But that's not the case for high income group. And this is very understandable because their sensitivity to crowding was also quite high. So they don't mind spending an amount which would have a lower levels of crowding in the MRT. So that is when they would choose the MRT system. And we could also see that when the flow of high income group in MRT is the highest, the usage of car is the lowest. So this directly shows us that people who are car users kind of give up on using car when the system is comfortable for them to use. But this comes at the cost of very low usage of MRT across middle and low income group. So this was the trade-off that we were talking about. So if we have to reduce car use, which is a major source of congestion and a major source of environmental pollution, it comes at the cost of shifting people who use car to MRT. And to do that, we have to make these systems comfortable for them. But that comes at the risk of making these systems non-equitable for people with lower incomes. So this was the trade-off that we were basically highlighting. And then we could also see a similar trend in the user surplus analysis. So we could see the user surplus for the high income group peaks around 150 to 250 Bangladesh taka range, whereas for middle and low income group is towards the lower fares. For the middle income group, it does peak around like 30 to 70 taka, but for the low income group, user surplus is the highest. So in very simple terms, the benefit for them or the welfare for them is the highest when the fare is the lowest, which is very clearly understandable. And this is the distribution of the consumer surplus values across the different scenarios. So we could see the consumer surplus in each of the scenario was highest when the fare was the lowest. There is a slight bump around the same range where high income users use, but still the highest value is when the fare is the lowest, which again is a very understandable finding. And the revenue of the entire MRT system is highest when the fare is between, say, 150 to 250 Bangladesh taka. This is also understandable because this is the time when high income users basically shift to, this is the fair value when they shift to MRT, giving up on their current car use. So this was the distribution of revenue, user surplus, and the flow across different income groups. But here we assume that the fare was the same across all the income groups. So we had just one fare for the entire MRT. But we also did an analysis where we assume different fare for each income group. So in this paper, we don't say how. To be honest, I also don't know exactly how we can do that. So for example, in Mumbai, we have different coaches with different fares. So that's a way. But that doesn't mean that we are having a different fare for each income group. But for the simplicity of analysis, in this study, we just assume that each income group somehow has to pay different fares. And if that is the case, how does the flow, the revenue, and the uh, user surplus vary across each of these scenarios? So this is a description of one of the scenario where you could say this is the price of metro for the high income group, price of metro for the middle income group, and this is the price of metro for the low income group. And then how does the revenue vary? So here also we could see the revenue is highest when the price of metro for high income group is somewhere around here. And uh, it's not very easily understandable, but I tried to summarize it in a table also so that we could clearly see the scenarios which produce the maximum consumer surplus, the maximum revenue, the maximum total surplus, which is the combination of these two, the scenario which produces the maximum flow for each income group, the minimum flow for each income group. So the first part of the table is the distribution of these values when the fare was same across all the income groups. And the second part is the distribution when the fare varied across income groups. So we could see that the maximum revenue is generated when the fare was 200 BDT for high income and 150 for the other two income groups. But this results in a relatively lower level of flow for the low income group. Meanwhile, the maximum flow for low income group can go up to 135,000, like 135,000 people if the fare for them is just 10 BD. And similarly, the flow of car can be reduced if, for example, here the minimum car flow was observed when the fare was slightly higher. And in this case, actually, this is not practically possible. We cannot make the fare of low income group higher than high income and middle income, but just for the analysis sake, because high income users are the major car users, and that was controlled in the model. So we had a variable to control who owned a car. So like the availability of a particular mode. So that's why with a very low fare for high income, we can produce very low usage of car flows. But practically speaking, such a scenario is not possible. But what basically this study kind of puts forward is the quantification of this trade-off, saying that if we have very low fares, it would be very equitable. It would have a very high usage of MRT across all sections of the society, but that would result in a higher level of car usage. But the car usage can be decreased if the fare is increased a bit. And how that is happening is basically because the crowding in the uh, system will be reduced. That would encourage high income users to use MRT, and that would then reduce car usage and ultimately also reduce the negative externalities such as environmental sustainability associated with car use. So this was the primary message, the key message of the study. But yeah, just to summarize again the key findings of the research. So what we could establish is that people sensitivity to crowding was dependent on their income. So it varied based on which income group they belong to. And this variation in their sensitivity also impacted the total demand for the system. So what we found was that the fares which produced highest social welfare were not equitable. And the fares which produced the highest highest usage among low income users were also producing high amount of car flows. So what we could basically do is that quantify this trade-off between equitable public transport and say environmental sustainability through the lens of reducing private vehicle use. So this was the key idea behind this work. But again, our study has a lot of limitations, and that must be mentioned. So we did not account for the variation in road congestion. Income categories again were not truly representative of the region. Our low income category was also not very low. So there exist people who belong to more lower income groups. Crowding in the bus was assumed to be constant. We did not account for various other important variables such as access time, egress time, crowding at stations. We also just argued that comfort in a train is due to crowding, but there are other factors which high income group people might look into. For example, air conditioning or the type of seating. So these might also influence their decision to choose an MRT system. And we did not have operators cost. So the basic idea is that we are not kind of giving any foolproof argument that the price should be increased or should be lower. But we're trying to say that this kind of trade-off exists, and the decision is for policymakers to make based on what they want to design. So if they want to design an equitable public transit system, then they should give priority to making the system have very low fares. But if they want to focus on reducing the usage of car, then they must focus on making public transit more attractive to the group of people who typically use private vehicles. So based on what a city or a region or the policymakers are trying to do in their particular region, they can follow these particular set of steps to either kind of give more priority to equity or more priority to, say, environmental sustainability or reduction of car flow. But our study kind of shows that it's possible and highly likely, especially in the context of Indian cities and the cities of Global South, that these two aspects might compete against each other. And there might be a trade-off that might be very important to tackle when we are designing these policies. So with that, I would like to conclude my presentation, and I will be very happy if you would ask questions to me, or if you have any doubts regarding my work, please feel free to ask. And these are just some of the references used in our work. And with that, thank you so much. Thank you again to NATPAC and all the organizing members for inviting me and giving me this platform to present our work. Thank you.
Any questions?
Yes, I have a few couple of questions. Good evening, sir. I'm Dr. Vasudevan, junior scientist from NATPAC, and thank you for your wonderful presentation. Sir, actually, I have two questions regarding the model and this result. Actually, you were covering the impact of crowding based on income for their earnings, right? So, basically, as did you consider any other behavioral aspects or any cultural aspects of the people who are actually looking into this crowding level? Because not only their income base, can we say that higher income group people are always looking less crowded public transport services? Other than that, if you look into some other aspects of or some other behavioral aspects, that will be, I think, more generic in terms, I think. So that was one of my observation. And secondly, sir, in that modeling part, in that derivation of utility equation, yeah, exactly this 15th slide, where you have focused on that ratio of the actual number towards this normal capacity. So that means that impact of crowding on the choice of travel, I mean, choice of the travel mode. So can it be a negative parameter? Because impact, if that impact increases, then automatically your choice to that particular mode will be decreased, right? Because if the capacity, I mean, the crowding level increases, then normally the choice to that travel mode will be decreased. So whether it will be a negative factor or not. This was the two observations that I have observed. Thank you, sir.
Thank you very much, Dr. Vasudevan, for the very nice questions. And yes, for your first point, I absolutely agree that the decision to give up car and to choose an MRT system is not alone dependent on somebody's income. And there are many other factors such as attitudinal factors, or now there are studies which look at life cycle events, like they follow them through many years and try to see how their decisions evolve. And that again plays a role at how they choose a particular mode, or the structure of a family, for example. If they have kids, that might again impact their decision of choosing a mode. So I absolutely agree that these are some aspects that we must look into. Gender again could be another important variable. But yes, in this study, we only looked into income as a variable. And what we assumed is that all the other factors are somehow incorporated through the error component. Like the error component kind of accounts for the impact of all the unobserved variables on the choice. But I am totally in agreement that in future we should somehow look into the variation or the sensitivity of crowding across these different variables, which could include socioeconomic variables, attitudinal variables, or decisions or certain events that happen over a long period of time. So I absolutely agree with that, sir. And the second question is yes. So this impact is supposed to be negative, and we observed a negative value only. So gamma was negative across all the models. So this is in accordance with the expectation. So travel time also negative, fare also negative, the impact of crowding also negative. So which basically means, as you correctly mentioned, that as the crowding level increases, their utility of choosing the mode would decrease. So that is how we incorporated that in their final probability to choose the mode and the final calculation of the flows as well.
Okay, sir. Sir, one more last question, sir. Whether this error times, the heterogeneity in that error is considered in the model? That,
Yes,
other unobserved variables?
Yes, we have. So this is not a simple multinomial logic model. This is a mixed logic model. Where we have assumed that the error components will vary across each individual.
Okay.
We have tried to cover that heterogeneity.
Okay. Thank you, sir.
Thank you so much.
Any other questions?
I have a few questions.
Yes, please.
This is Rajesh Krishnan from ITSP. I have come to NATPAC for a meeting and have gate crashed your presentation. Sorry about that.
I'm glad, sir, you could attend.
So the first question is, in some of the suburban rail systems, there are different classes of travel. For example, in Mumbai, there's first class and a standard class. And same is true with some of the suburban lines in London, for example. So is this something you can incorporate into your framework in order to get a more optimal solution, so to speak?
Yes, sir. I think that's a very nice idea, and we could easily expand this model to account for the sensitivity towards different classes or different, for example, a kind of car, like the car in the metro system, has a different price. So we could ask people directly their choice of the car based on the price, or we could ask them, instead of choosing the mode, or incorporate it in the survey in a way that they also mark the choice of the bogie or the class. I think this can be easily extended. But you have to then design the survey like that.
Yep, and which could also presumably give an estimate of the capacity needed.
Yes, absolutely.
For first class versus standard class.
Yes. So again, I should have mentioned this. So this is a stated preference survey where we asked people about, say, a hypothetical scenario, but this survey could also be done for revealed preferences, which is like after people are actually making their behavior, we could ask them about their choice and then about the various variables that influence their choice. I believe that by doing that, we could come up to a much more reliable estimate of the flow or the level of choice. So now SP surveys are often criticized to have these hypothetical bias because they don't have a real stake in choosing these things. So they just mention, okay, they will choose, but they might not also. But we could also do we could also do like reveal preference surveys where we could ask people about their actual behaviors. So that might help us to have more reliable estimates. But if we have to test how different capacity levels or different fare levels impact choice, then we might have to do a stated preference survey, but we can then combine it with some reveal preference elements to make it more realistic or more close to what is actually happening. Thank you, sir.
My second question is, it's rather comment-headed question. Probably there's an implicit assumption that different income groups are homogeneously distributed spatially because you are treating the entire public transport system as a whole. And there is another dimension where different lines could be differentially priced based on the distribution of my income groups. Any comments on that approach?
Yes, sir, I absolutely agree. And somehow our model ignores that as well. So one way to expand that would be to somehow incorporate spatial correlation within the structure. So now what we do is that we somehow incorporate individual levels heterogeneity. So whatever variables we haven't observed for me, for example, for a person, we are somehow accounting for the impact of that in the model. But there could be some variables which are spatially distributed, like Tobler's law, like people who are close to each other are more similar to people who are far away from each other. So we might have to incorporate an error term which accounts for spatial unobserved variables. So I have to think a bit to exactly on how to do that, but it's a very interesting idea to. So in some linear regression type work where the outcome variable is continuous, spatial error or spatial lag model is very common. And some studies in departure time choice and residential location choice have also extended that same idea to discrete choice models as well. So it will be very interesting to review those work and kind of incorporate such a structure where spatial autocorrelation between variables, meaning that the similarity or the differences is accounting or coming because of some spatial characteristics could also be addressed. I think it's not so easy, but I'm sure that there have been studies done on that. I would be happy to go through them and try to incorporate in this structure so that our model can be extended to account for those aspects as well. I think it's very, very important. Yes, totally agree.
My third question is, looking at one of your analysis slides, the increase in the or decrease in the public transport the usage of high income group and the corresponding increase in the car trips do not match, especially at the table when you look at the numbers, but even here. So could you please comment on that, or am I missing something here?
So, as in, you are saying it's not equal or something like that?
I would have expected a strong correlation between the decrease in public transport usage of high income group and an increase in car flow. But that correlation seems to be weak when looking at the numbers.
Right. I would have to go through the data in detail to exactly know why there is not a very direct correlation, but I believe that not all high income users have car also in the data. So we could see that from the description that currently only 16% of the users in our currently sampled respondents were using cars, and but 40%, sorry, 36% of them were classified as the high income group. So not everybody who uses a car, not everybody who is classified as high income group has a car or uses car. So that could be one of the reasons why the correlation is not as stark, but at least there is a trend, clear trend that the scenarios where the usage of MRT is the highest among high income group, that is also somehow the scenario where the car flow is the lowest, even though the relative change is not as stark. And that could be because not everybody in the high income group is also currently a car user. And that was somehow accounted by this availability factor, which basically accounted the current availability of cars across users in the sample. So that could be one of the reasons, but I have to go through like the data in more depth to clearly understand like why that's happening. But I believe that might be the reason.
Thank you.
Thank you.
Thank you, sir. That was actually
No other question. Huh? Varun, Samson here.
Yes, sir. Yes, sir.
It was a nice presentation. Thank you for that. I have one question, maybe something connected, like what Rajesh Krishna. She is how to quantify the pollution level that is created by maybe a car or the personalized vehicle, and how to how we will charge, how we will put penalty for that. And suppose somebody is using a car and it is creating some congestion or pollution or something, that effect will be there in the stream. And on the other hand, you have the public transport system, and that public transport system is maybe utilized or underutilized some cases. And in your case, you had gone like a crowding case also you have mentioned. But my question is, how to charge these people, those who are using that personalized vehicle, and that that maybe the revenue can be given to the or to subsidize the public transport system. How we can make do a the evaluation or evaluation for that? Do you have any idea?
Thank you very much, sir. I think this is a very important aspect. So the first part of the question is like the ways to quantify the pollution. So this study doesn't do that. This study doesn't really quantify the level of pollution, but during some other studies, we went through some literature. So there are, I think, one of the ways to they just assume some number, like based on the VKT, like the vehicular kilometer travel. They assume, okay, this much travel emits this much emission. But now there are more robust studies which kind of calculate the impact of braking and the impact of say other things on this emission. So they kind of incorporate those aspects, but that requires very minute level of data from the car users, for example, some kind of GPS data or some kind of very finer level of data, like every 5 seconds, so every 10 seconds, so that we can identify how their acceleration or their speed is varying, and that can be easily then, based on certain assumptions, can be linked to the amount of emission. But that is very data intensive. And to the second part of your question, sir, how to really charge them. So, so there are two aspects, sir. So one is, so we also did, so this is not this research, but another research that we are currently working on. We did a small experiment here in Hiroshima where we gave people incentive instead of charging. So charge itself has a negative connotation among people that it is a tax. And incentive, on the other hand, kind of gives them the idea that, okay, this is a positive thing. So there are, so if we have to describe the travel demand management strategies, we can divide it into three groups broadly. One is the pricing based strategies, which is like similar to a congestion pricing scheme, where we identify regions, say we take up a city, say Kochi, and we identify regions where it's highly congested, and then charge areas to which is entering the region. So that is very similar to a congestion pricing scheme. But then, as you very rightly mentioned, how do we cross subsidize that value to public transit? So we need to have that framework to really establish, okay, whatever the charge is collected is then transferred to, say, the development of bus system or metro system. And then another very practical challenge here is that the stakeholders of each of these groups might be different. So the bus system might be run by a different organization, the charge might be collected by a different organization. So how to convince them to sit on the same table and somehow transfer these funds? So that's the first thing, like something similar to a congestion charge. But then how to translate it to like the emission, I'm not exactly sure. But one idea could be that we can install some sensors now some low cost sensors are also available across the city and monitor the air quality. And we identify regions which are highly polluted, for example, based on those sensors. And just similar to congestion pricing, we can have a scheme called environmental pricing, just to stop the entrance of vehicular flow in that region based on data, based through these sensors. So that is one way. And the other way, sir, is like this is the pricing scheme. The other way could be some supply-based scheme. So we control parking in a region. So we incentivize people to go to that region. So there is no parking available at all. Just an example. Or we could put some limits on the number of cars entering a region. Just example. These are some supply-based measures can be done. And the third is like supportive measures, which could be incentive provision. Like we give them some rewards, like government can have some scheme where if you use public transit, you might get some coupon which you can use later to get do some shopping, for example. So this kind of incentives can be done, but then again, this again should be judged based on how much cost it will bear and how much benefit we can actually reap. So we might have to do some kind of cost benefit analysis to convince the policymakers to implement such schemes. And the most simplest solution, like a TDM solution, a transport demand management solution, is like information. But in our study, we found that information has no impact. Like if you give people some information, just tell them that your travel is causing this much emission, so you should shift. Just information based on some app. Like one study we did where we developed an app where the moment they entered CBD of the region in a car, so through the GPS, we somehow identified the mode of the travel. So they got a pop-up saying that next time try to avoid, say, a car, but that we found has no impact on their transport mode choice. Rather, we found provision of incentive through actual monetary incentives had impact on them choosing, say, sustainable modes of transportation. But then the question is, how long can we continue this incentive? So in some literature, it's evident that once we stop these incentives, people go back to their original mode of transportation. So again, then it's very costly to continue such incentives as well. So sorry, I gave a very long answer, but primarily we could have certain pricing-based schemes based on actual emission levels in some regions, but we might have to install some sensors to measure these pollution across, say, any city.
Thank you, Varun.
Thank you, sir.
So there is another question from Shalini ma'am. How about including consideration on time and cost to be spent on first and last mile connectivity of the journey? Because mostly time is money, especially for high income group.
Yes, I totally agree, man. Like we didn't really account for the first and last mile connectivity. Like access to the public transit is another major barrier why people don't use public transit. Even though the total travel time in the train might be low, but the travel time to reaching that stop is quite high. I totally agree. That must be accounted for. And as Sir mentioned previously, that again is a spatial variable in the sense some areas might have a very high amount of cost to reach to the station because of however the station is designed or the space it is located in, and some areas might be a bit easier. So yeah, I totally agree that those variables must be accounted for when we are doing kind of a holistic study on why certain people don't use public transit.
Thank you, sir. Any other question? Thank you, sir. That was actually a fantastic technical talk on quantifying the trade-offs between environmental sustainability and equity in welfare for mass rapid transit system. Now, I would like to invite Dr. Sabita Enam, Senior Scientist, Water Transportation and GIS Division, NATPAC, to deliver the vote of thanks.
Thank you so much. I'll stop sharing my screen.
Thank you, sir. Respected Director NATPAC, distinguished participants who participated in this event, both offline and online, and the speaker of today's session, Dr. Varun Varghese. On behalf of KSCSTE-NATPAC, I would like to extend a heartfelt vote of thanks to all the individuals who have made this event, TransTech Talk Series 5, a resounding success. First and foremost, we express our sincere gratitude to our speaker, Dr. Varun Varghese, Assistant Professor, Hiroshima University, Japan, who have generously shared his knowledge, insights, and experiences. Your presentation has enlightened us about the topics like environmental sustainability, equity in welfare, and also he had thrown some light on the based on the data from Dhaka, Bangladesh, about estimating the sensitivity of different income groups to crowding and equity, and quantify its influence on the demand for MRT system, etc. I would like to express my sincere thanks to you, sir, for your time and dedicated effort for gracing us with your experience. Thank you, sir. And a special thanks goes to all the participants who has actively engaged in this event. Your presence added immense value and significance to this gathering. I would like to extend my thanks to all the participants who participated both offline and online and made this event a grand success. And we also extend our sincere appreciation to all the staff members of NATPAC who have participated in this event. Once again, thank you, everyone. We hope to continue this journey of knowledge sharing and collaboration in the future also. Thank you, everyone.
Thank you so much. Thank you. Thank you.
When will be your next visit to India?
Sir, I'm not sure, but I'm planning to visit in September, sir.
September, okay. Like